All right, good day. Here we are, section 4.6 today, where we are factoring, and this is just a general overview. I don't want to say just a general overview, but when you are doing problems that you don't really know what's coming, I see a typo here, you want to develop a general review and some steps maybe to determine how to factor a problem. So, okay, so that's what this is all about. A little bit challenging sometimes when we get into the heavier, unfamiliar looking trinomials and binomials and the like, or problems in general. Okay, so here's the steps. I'll leave that to you to read over a couple of times as you will, or as you're doing these problems. Okay, your homework problems or anything else you may encounter along the line. All right, so let's go on to our first example. And I like to point out in step one, if the polynomial has a greatest common factor other than 1, then factor out the greatest common factor. So in the initial problem, we want to make sure that we're doing step one because a lot of times you will factor out that lead coefficient. It may be a 2 or larger, and then you're left, after you factor it out, then you're left with the easier factorization of the trinomial or binomial, whatever the case may be. All right, but we've got some examples and I'll show you as we go as well. All right, okay. Let's see. All right, here's practice problem 1. And as I previously mentioned, when I see this problem here, I've got a 3 in the front. This is not a trinomial by any means. This is a binomial. It has 2 terms separated by a minus sign. And what I want to do is just take out the 3 if I can. So if I got a 3 and a 27, I can factor out a 3. And then I want to do the variables. I got an x to the 8th and x to the 6th. So the one I can take out is the smaller exponent, so it would be x to the 6th. Okay, putting back what's left over, I'm going to have x squared. 3 divided by 3 is 1. X to the 8th divided by x to the 6th is x squared. And then that's going to be minus 27 divided by 3 is 9. And x to the 6th divided by x to the 6th is 1. And 1 times 9 is 9. So this is what I'm left with here so far. But now, sneaky devils that they are, I've got another factorization I can do. Because now if I look at this as the main problem, the x squared minus 9, I can say, oh, that is a difference of 2 squares. X squared is squared, and so is 9 a square number. So I can go ahead and factor that as well, and that would be x minus 3 times x plus 3. And then I'm going to bring down the 3x to the 6th. So this is my final answer here. Okay, practice problem 1. All right, here's practice problem 2. So you can see these, they're like a little bit intimidating. They're trinomials, but boy, they look kind of large and large exponents, and I got common factors all over the place on this one. But I'm going to start with the coefficients to say, can I factor out something from 4, 40, and 100? And the answer to that is yes, I can factor out the whole 4. So the 4 comes up, then I've got an x to the 4th, x to the 3rd, and x to the 2nd. So that means I can take out the x to the 2nd power. And now I'm going to put back what's left over. 4 divided by 4 is 1. X to the 4th divided by x squared is x squared. And then how about what? 40 divided by 4 is 10. X cubed divided by x squared is x. Copy down my plus sign. And then I've got 100 divided by 4 is 25. And x squared divided by x squared, well, that's 1. We take the 1 and multiply it to the 25, so the 25 remains the same. Okay, and now I've reduced this x to the fourth problem to an x squared problem. So now this is a trinomial where the lead coefficient is 1, and oh, that's the easy one that I can just fill in. So I got x here, x here. They're both plus signs in the problem, and I'm going to put plus signs here in our answer. Okay, then I'm looking for 2 factors of 25 that add up to be 10. Well, that can only be 5 and 5. And that makes this a perfect square trinomial. This one here is a perfect square trinomial. And all I have to do now is bring down the 4x squared. Okay, and this is my answer for practice problem 2. Okay. All right, how about practice problem 3? Anything major going on here? Let's find out. Pull out the greatest common factor. All right, so I just have a 1 here, so it's going to be between y to the 4th and y squared. I can take out the y squared. And then I can put back what's left over, which is going to be what? Y to the 4th divided by y squared is y squared, plus 36 divided by 1 is 36. Y squared divided by y squared is 1. 1 times 36 is 36. It stays the same. All right, and now on this problem, if I look at the parentheses, I'm looking for something else I can factor. Notice that this is the sum of 2 squares. So if it's the sum of 2 squares, I can't factor that anymore. No, can't do it. It's got to be the difference of 2 squares. All right, so what does that mean? That means this is my answer for practice problem 3. All right, check it out here. I've got 6x squared minus x minus 15. I can't take out anything with the 6. So that means it's a trinomial, so that means I've got to do the grouping method. All right, so let's do it. 6 times 15. Well, that looks like 90. 2 factors of 90 with a difference of 1. Well, what are factors of 90 that we know? Anything times 10. Anything times 10 is the anything with a 0 after it. So that would be 90 times 9 times 10. 9 times 10 is 90. And if I subtract 9 and 10, 9 from 10, I'm going to get a positive 1, but I need a negative 1. So that means it's going to be positive 9, negative 10. 9 times negative 10, let's say it that way. That's negative 90. And 9 minus 10 is negative 1. Okay, so that means, oh, I got to make that negative. That's what was troubling me. 6 times negative 15 is negative 90, so it's beneficial to use the sign. All right, so this checks out. Here are my 2 factors that I'm going to use. And now I can write this up as 6x squared plus 9x minus 10x minus 15. Okay, I got my 4-term polynomial, so that means I can group them into 2 binomials and then factor each of the binomials. So on the left side here, it looks like I can take out a 3 and an x. Between the 6 and the 9, I take out the 3, and then I got x squared and x. So I take out the smallest exponent, which is the x, and I'll divide back what's left over. 6x squared, no, let's do it. 6 divided by 3 is 2, and x squared divided by x is x. Plus 9x divided by 3x is 3. Then I got a minus sign here I'm dragging down. And on the right side, between the 10 and the 15, I can take out a 5 and then say what? Okay, how about, this is really negative 10, don't forget. I put that parentheses there. Negative 10 divided by negative 5 is 2. And that's going to be x divided by 1. That's x. And then I've got negative 15 divided by negative 5, which is positive 3. And again, I'll start reiterating, whatever this one is that in that first binomial, then it's going to be the same one in the second binomial. All right, so keep that in mind. A little shortcut after a while doing these. All right, so let's see. I've got the common binomial factor of 2x plus 3, which means these are gone. And I just say what's left over is the 3x minus 5. And we're done. Let's see, here we go with 3x to the 5th minus 81x squared. So 3 and 81, well, it looks like I can take out the 3. And then between x to the 5th and x squared comes out. Divide back what's left over, and I've got 3 divided by 3 is 1. X to the 5th divided by x squared, x cubed, minus, and what's 81 divided by 3? 27. X squared divided by x squared is 1. That's multiplied to the 27, so this is what I've got. All right, and after multiplying or factoring out that 3x squared, now notice I am left with a, well, it's not a difference of 2 squares, but it's a difference of 2 cubes. Right, 2 cubes. So that means, let me think here a moment now. That means a difference of 2 cubes comes from a binomial multiplied to a trinomial. And now's the time I want to reach out and grab a little bit of soap and fill in my signs. All right, the sign is going to be, in the first binomial here, is going to be the same sign that's in the problem. So this is the minus sign, so it's going to go here. The O in soap stands for the opposite sign of my sign between the first and second term of the trinomial. All right, so that means it's going to be positive is going to go here. And then my last sign, the second sign in the trinomial, is AP, which stands for always positive. And it is, it's always positive. All right, so we got our signs set, and now we're ready to fill in the rest. I want to know, what is the cube root of x to the 3rd? Well, it's just simply x. What's the cube root of 27? Well, that's going to be 3. And then I'll fill in the rest, the trinomial here, by way of the first term of the trinomial is going to be the first term of the binomial squared. The middle term is going to be these two guys multiplied together. Ignore the sign. Our sign has been established by the soap. So I've got an x and a 3, so when I multiply that together, I get 3x. And then my third term in the trinomial is going to be the second term of the binomial squared. So that means this is a 3, so squared is going to be 9. And then that's my final answer. X minus 3 times x squared plus 3x plus 9. Complete. Check that box. I forgot which one that is. Practice problem 5. Good. All right, in practice problem 6. Yikes. We've got a mess here. All right, I'm looking at the 3 first, this 3, to say, can I take that out? And the answer is yes, with a 3, 6, and a 3. So if I take the 3 out, that'll be out front, of course. And then I got A's that are common and B's. All right, so I got an A squared, an A squared, and an A squared. Oh, the whole A squared can come out. Then I got a B cubed, a B squared, and a B. And it looks like the B will come out. The B with the smallest exponent, which is B to the first power. And when I put back what's left over, wow, what do I get? B squared, because it's 3a squared divided by 3a squared, you know that's 1. And b to the third divided by b is b squared. Plus 6 divided by 3 is 2. Then I got a squared divided by a squared, which is 1. Multiply to the 2, stays 2. And then b squared divided by b is b. And about a minus sign here. 3a squared b divided by 3a squared b is 1. Now the idea, can I factor this b squared plus 2b minus 1? All right. So if I've got negative 1, I need 2 factors of negative 1 to add up to be 2. And I don't think we can do that. Negative 1 times 1. Remember, if it's negative 1, this number, one number has to be negative, one has to be positive. And if I got 2, that it doesn't work. I mean, I just can't factor it anymore. So in that case, this is my answer. Because this trinomial is unfactorable. But we were able to answer the problem and factor it, but that's all we could do. So we stop and say, okay, I'm done. Practice problem 7. I've got, all right, here's practice problem 7. And you're kind of inclined to maybe group this because it's a 4-term polynomial, and you hear me say it all the time. I'm going to group that 4-term polynomial. But there's one step better you can do if you can recognize it, is to say I've got this here trinomial. And then it's going to be minus b squared. All right, so if you catch that and say, oh, let's factor this trinomial here. That's a perfect square trinomial. The least coefficient is 1, so that's easy to set up. And I've got an x and an x, a minus and a minus for my signs to work. And then I'd have a 5 here and a 5 here. And then this would be minus b squared. Okay, this is quite interesting now, because I can rewrite now the first 2 terms here. And I could rewrite that to be x minus 5 squared minus b squared. And now I have what's called a difference of 2 squares again. So if I do have a difference of 2 squares, then I'm going to write this up as, let's see, I'll do something a little fancy here. And I'm going to write this up in my brackets here. Brackets and parentheses are the same, so same usage. So I'm going to put an x minus 5 here times an x minus 5 here. All right, my signs are going to be a minus and a plus. And then my answer here would be a b and a b. I'll finish off the binomials here as b and b. So my little answer on the left side, I guess I could write as x minus 5 minus b times x minus 5 plus b. And I guess that's okay. I'm done. That's it. If I did it another way, like let's say I grouped this 4-term polynomial, let's stop and see what happens, shall we? All right, let's try that again. Okay, here's the problem as it was written originally. And that means I'm going to look at this and, we get kind of lazy with our brain, and that's to be expected. But it happens to me when I look at that to say, oh, it's 4-term polynomial, so I'm going to group them. And if I group it like this, the left side I'm going to take out an x, and I'm left with what? X minus 10. Okay, check that, make sure I'm right. Of course I'm right. And then over here I got a plus sign, and here I can't factor anything out. What would I do though with that? If I can't factor anything out, is there something I can do with that? And the answer may be yes, it's a difference of 2 squares. So that means that's going to be 5 minus b times 5 plus b. And this is all I can do. It's all I can do. So I'd have this as opposed to what I've got up here. All right, so by the grace of factoring, this is our correct answer. This is what we would do. And I guess you check that by multiplying this together, because I've got these 4-term polynomial, and it ends up being 2 trinomials, I guess you could say. But nevertheless, this one ends up being wrong. You want to catch that trinomial at the beginning of the problem, this part here. All right, so be on guard for that. Look for that, and when you have a 4-term polynomial. All right, check out this problem. X to the 6 minus 1. All right, so whenever I have a trinomial or a binomial and it's a power raised to something larger than 2, I'm looking for something that's probably going to be a repeat factorization problem. All right, just put that in your head. It's possible it could happen. All right, so I've got x to the 6 minus 1. Now, can I do something with that? I can't factor anything out of it. Is this a difference of 2 squares? Is x to the 6 a square number? And the answer is yes, because I could write this up as, well, my lead coefficient is still 1, so I'm going to call it an easy problem, and I'm going to fill it in. All right, as long as it's a difference of 2 squares, it'll work. So let's see, what's the square root of x to the 6th? It's x to the 3rd. What is the square root of 1? Well, the square root of 1 is 1. And then my sign would have to be 1 minus here and a plus here. And if this is x to the 3rd, this is x to the 3rd. And if this is negative 1 and this is negative 1, well, negative 1 times what equals negative 1? And it is 1. So now look at what I've got. I've got a mess. I've got a big problem here. I've got a difference of 2 cubes now, because x cubed is a cube number and 1 is a cube number. So I got them on both sides. So this one's with a minus sign, this one's with a plus sign. So let's do the minus sign first. We know it comes from the binomial times the trinomial. Okay, and I want to take my signs and get those straight. So using SOAP, the same sign is going to go here, opposite, and this one's always positive. So I've got my sign set up. And now I want to take the cube root of x to the 3rd, which is x, and the cube root of 1, which is 1. So far, so good. So now what goes here? The first term in the trinomial is the first term of the binomial squared. So I'm just going to square it. My middle term are going to be these two numbers multiplied together, not counting the minus sign, because the sign has already been established to be positive. So what's 1 times x? 1 times x is x. And then my third term in the trinomial is going to be the binomial, the second term in the binomial squared. So that gives you 1. All right, so this part's done for the first binomial in my solution, but now I got to do it again for the x cubed plus 1, this problem. And this is all going to be one answer. Crazy. Okay, so let's try it. I'm going to do the same setup, and what do you think is going to happen here with these signs? I'm going to have a sign here of, well, now I'm doing this problem here with a plus sign. So that means I'm going to have a plus sign here, a minus sign here, and a plus sign here because it's always positive. All right, the cube root of x to the third is still x, and the cube root of 1 is 1. So these should be the same as the top one except for that sign. So now I'm going to square the first term, multiply the two terms, and that'll be my middle term. So 1 times x is x. And then I'm going to square the second term of the binomial, and that's going to give me 1. All right. And everything's done. It's complete. It looks good. And this is my final answer for that problem. So you mean to tell me that in order to get my answer, that I can verify it by multiplying all this together? That's what it's saying. And it is, because if I multiply this first one together, I'm going to get x cubed minus 1. So let me change colors here a little bit. So this one is going to be my answer for that, if I multiply it together. And this guy, oh, can't use that. How about, what's a pretty color? I'll use black. Okay, there. And this answer, when I multiply it together, is going to be this one. And if I multiply these two together, the x cubed minus 1 times the x cubed plus 1, I'm going to get this top answer. And you can try it out to prove for yourself. It's kind of fun. That was practice problem 8. And that completes section 4.6. Okay, congratulations. We are ready for nothing yet. We're going to solve equations by factoring our next time, our next meeting. Okay, thank you. Talk to you again.